A very good afternoon. I welcome you all in our afternoon session. I welcome our today's expert, Dr. G.D. Ransing Chung, RN. I welcome you, sir. Dr. G.D. Ransing Chung, RN is working as Associate Professor in Transportation Engineering Group, Department of Civil Engineering, IIT Roorkee. Apart from teaching, he has also involved in national administrative work like member of State Technical Agency, Pradhan Mantri Gram Sadak Yojana, member of Draft Rules on Construction and Demolition Waste, member of H8 Committee, H3 Committee, and H6 Committee of Indian Road Congress. As we all know, India is the homeland of one of the 7 wonders of the world, the Taj Mahal. He has rendered his services in the beautification of the surroundings of the Taj Mahal with pigmented sandstone pavements at the Taj Ganj. He has also helped in developing airport stations for the construction of runways and taxiways. His services spread internationally, where he was actively involved in design and vetting of international airport at Mauritius and Assumption Island, Seychelles. Currently, he has been awarded prestigious sponsored research projects to the tune of more than 150 lakhs. He has published over 100 research papers in peer-reviewed journals, conferences, and technical magazines. Dr. G.D. Ransing Chung, RN is the receiver of many prestigious awards like IRC National Gold Medal 2017, IRC Pandit Jawaharlal Nehru Birth Centenary Award 2015, INAE Innovative Student Projects Award 2019, Outstanding Contribution in General Reviewing by Construction and Building Materials 2016, and many more. Dr. G.D. Ransing Chung, RN is well known in the country for research work in utilization of reclaimed asphalt pavement, that is RAP, for construction of rigid pavements. So today he is going to deliver his expert lecture in use of RAP in rigid pavement construction as a sustainable approach. So I request Dr. Ransing Chung to please begin with his lecture. Thank you.
Hello.
Sir.
Yeah, am I audible to you all?
Yes, sir.
Yes, sir.
Then, yeah. So may I know who was introducing me? At the very beginning, I happened to miss out. Yeah.
I'm Dr. Shailja Baba, Assistant Professor in Civil Engineering Department at Dr. B.R. Ambedkar, NIT Jalandhar.
Hi. Yeah. Thank you, Dr. Shailja. Thank you so much. Thank you so very much for introducing me in a very fantastic way. Yeah. So, good afternoon, everybody. This is G.D. Ransing Chung, RN. I am very delighted to have this opportunity today via this platform. We shall be interacting each other through video conferencing because of outbreak of COVID-19 pandemic. We are missing the opportunity to have the interaction physically. So let us pray to Almighty God to help us out from this difficult situation. And nevertheless, we are still doing pretty well in such a tough time. We still can go ahead sharing thought process to each other and enhance our knowledge continuously. So I acknowledge my sincere thanks to Dr. Hemant, the convener, Dr. Rajiv Kumar, Dr. Shailja Baba, the coordinators of this program, and their teams for inviting me to deliver this lecture in this 1-week online short-term course. I convey my best wishes to all of them for a grand success of this course. Also, I take this opportunity to extend my sincere thanks to the participants who are enthusiastically joining me in this discussion. Indeed, I consider this opportunity is a fantastic platform for me to enrich my thought process through this discussion. Well, without further ado, I shall now invite you to my lecture, and I hope we would have a fruitful discussions in the course of the discussion. The topic that I have chosen for today interaction is use of wrap materials. I'll just come up with my presentation slide. Is it my slide is visible to all of you?
Yes, sir.
Right now, which slide you are visible?
It's an administrative building, sir. First slide.
Perfect.
Yes, sir.
Perfectly fine. Yeah, perfectly fine. So, yeah, I was telling you the topic for our discussion today is use of wrap materials in rigid pavement construction as a sustainable approach. Yeah, in today's topic, we find three distinct characteristics such as wrap materials, rigid pavement construction, and sustainable approach. To simplify the topic, let me put in this way, because some of our participants may be from the UG and PG students who might not have had a good exposure on the wrap materials. So I'm taking up in that manner. So those who are well versed with the wrap materials, please you bear with me for a while. The terminology wrap is no longer a new one for all of us, particularly for the people who are actively involved in the highway construction projects. A wrap material is an aggregate matrix coated with an asphalt film, and the coating may be done fully or partly. Now, basically, it is an aggregate particles which is being engulfed with asphalt film. Now, the details of the wrap material would be discussed in my following slides. Then next, coming to the rigid pavement. Yes, this is one type of pavement. As we know, there are broadly two types of pavements, flexible pavements and rigid pavements. So the rigid, by the name itself implies that the structure is stiff and very rigid in nature. So the rigid pavement is basically a pavement which is built with a concrete mix having height modulus of rupture of about 4.5 MPa. Hence, M40 grade of concrete is normally considered to be suitable for constructions of rigid pavement. Also, it is being recommended by the MOD clause 602 for the constructions of rigid pavement. Now, coming to sustainable approach. A sustainable approach here, I have suffixed this sustainable approach in my topic for the reason that through these research findings, we would be able to contribute towards ecological, economic, and social problems. So as a result of which, I have chosen this topic for today's discussion. Honestly speaking, the topic that we have today is very lengthy, and it would not be possible for me to deliberate on the entire chapters elaborately in this 1.5 hours. But we shall be able to capture some of the important informations pertaining to usage of wrap materials for rigid pavement construction, which is why I have deliberately picked this topic for today's discussion. And moreover, usage of wrap materials in rigid pavement construction is a new concept as of today. You might have heard so many times about the usage of wrap materials for flexible pavement construction. That basically in formulations of the bituminous mix, and there are well-established guidelines for usage of wraps in bituminous mixtures. But for rigid pavement construction using wrap materials, the country is still in a struggling stage. Therefore, this lecture may be of your interest. Now, this lecture is a partial part of the findings of one of my ongoing research projects, which is being funded by NBCC IITR R&D unit. The title of the project funded is a pragmatic approach towards using reclaimed asphalt pavement, RAP, for bituminous mixes and pavement quality concrete. So, before I take up the core presentation, I shall like to apprise in brief the background of the research work from which I have picked my presentation topic so that we could appreciate better about my presentation later. Please don't consider me that I'm taking up a research project presentation, because the manner I am going to appear in front of you for a while is quite similar to that fashion. Since the objective of the particular research project were to address the usage of RAP for bituminous mixture and pavement quality mix. So sorry here, I think I should have clarified, at the very beginning. I may often, quite often use the terminology like PQC, rigid pavement, cement concrete pavement. I would say they are same. When I term PQC, I am talking about the cement concrete pavement. I am talking about the rigid pavement. So I hope you would follow me. Having said that, these mixtures are composed of different sizes of aggregates. Hence, for better understanding of the mixed behavior, after inclusions of RAP materials into the conventional concrete mix, it is imperative to study the efficacies of RAP materials by dividing them into different sizes. As we know that the concrete matrix is basically, it is a combination of aggregates of different sizes. We have coarse aggregate, fine aggregates, cement, and water. Then when this, yes, in some, in advanced concreting or concrete mix, we use super plus sizes, or we use some mineral admixtures, and we use some pozzolans and fibers and so on and so forth. But when I'm talking about the conventional concrete mix, I would limit my discussion only up to the chemical admixtures. Okay, so for formulations of a good quality concrete mix for the constructions of rigid pavement, it is imperative to understand the physical properties, mechanical properties, durability properties of the selected aggregates beforehand. So as a result of which, what I have done is, rather let me not say we, because it is a combined effort, and in fact, the research works, they have been executed by the different research scholars. So the outcome of this research work is through my research scholars. So I am just trying to share the findings which have been intimated or contributed by the different research scholars. So what we have done is, the materials have been, the RAP materials collected have been deciphered into two different sizes, coarse aggregates and the fine aggregates. Coarse aggregates, they are the aggregates which are retains on 4.75 mm ISC, as that we know. And similarly for fine aggregates, the materials which was retains on passing 4.75 mm ISC. So in that way, what we could do better is, we would be able to evaluate the efficacy of these aggregates size-wise. What happens if they are bringing together? Okay, and what happens when they are being used in a separate manner? So in order to understand the efficacy of this material in a separate manner, we have tried in that way. Then, since as you know that every funded research project has its own timeline, research activities needs to strategize effectively, for which I had to engage 3 different PhD scholars for this particular project. Now, here, to address the first part, that is, what we have done is, we try to understand the efficacy of RAP material, considering only the coarse fraction, And then for this cost fraction, we have given the title of use of RAP for pavement quality concrete. So this particular research majorly deal with the cost fractions of RAP materials, and the responsibility was assigned to Dr. Surendra Singh. Now currently he is assistant professor in the Department of Civil Engineering, IIT Madras. He is also one of the speakers of this short-term course. Most probably, he shall be interacting with you all tomorrow if you happen to join him. In fact, had I knew it before, he is also one of the speakers in this short-term course. I would have, requested him to, come up with this topic so that you can have the better understanding with him, because he was the, the concerned research scholar who was closely associated with these findings. Nevertheless, being the principal investigator of this project, I can definitely share the findings of our research work. Sorry. Similarly, the second part of the research project, that is, as I mentioned earlier, use of fine RAP for PQC mix. This responsibility was assigned to Ms. Sarah Mariam Abraham. Now, she has completed her investigation part, and she would be defending her PhD examinations on July 3rd. And she is the expert of the fine RAP materials uses for constructions of rigid pavement. But in my today's presentation, I'm not going to cover this component. And lastly, the third part is the studies on the uses of RAP materials for bituminous mix. This responsibility was assigned to Dr. Kumari Monu, and she has completed her PhD, and she has been recently awarded. And so in that way, I have 3 different components on this particular topic. Yes, beyond this, our research is going on for the different, the applications, like for a roller compacted concrete pavements, which is again a very emerging research, which is being handled by Solomon Debarma, that let me not cover as of now because he is still pursuing. So what I wanted to say, my whole intention behind introducing my research scholars are, see, the research was conducted in a laboratory in a very comprehensive manner, considering the different sources of RAP and edges of the pavements. As we know, the quality of aggregates would be affected because of the bitumen content, because of variations of the bitumen content, and this bitumen content variation would again influenced by the age of the pavement, aging process of the bitumen. So therefore, in our study, in the first phase, we have collected the RAP materials from the pavement sections, which was of the 5 years old, and the second RAP materials was collected from the pavement sections, which was 10 years old, more than 10 years old. So now I have understood that now we have 3 experts from the RAP materials applications for rigid pavement construction. So now, therefore, I owe a big thanks to these 3 talented research scholars who have on this research work and given me a good insight of these RAP materials. As I mentioned that, yes, a few research scholars are still working on it. I hope they will be giving their best in future. Now, the topic is pertaining to constructions of rigid pavement. So I thought of sharing with you this slide. This is a rigid pavement, and this particular pic was collected from 4 landing work from Hiran River to Sindhu River. It was of part of the National Highway number 12 under the National Highway Development Project phase 2 in the state of Madhya Pradesh. So I had the opportunity to land up in this particular project as I was invited by the National Highway Authority of India and the consultant and contractors to address few issues. So in that during that course of the site visit, I could capture this. So I'm just sharing with you to show you the receipt payment. On the right hand side, the payment section is the receipt payment section, receipt payment slab, or I can say PQC slab. And on the left hand side is the DLC layer, dry lean concrete. So when I talk about the constructions of receipt payment, I cannot ignore the dry lean concrete layer. So I shall be touching briefly the dry lean concrete part also. In my presentation, I shall be covering in these 4 different heads. First of all, I shall be discussing on the wrap materials, and followed by wrap materials for dry lean concrete. As I said, dry lean concrete is being served as a upper sub-base in the receipt payment system. I hope most of you must be knowing that in the receipt payment system, we don't term as base course. We don't have base course. We have sub-base. So though the GSB is also a sub-base, but we term as a lower sub-base and DLC as a upper sub-base. And then followed by wrap materials for PQC, basically the receipt pavement or cement concrete pavement. And finally, the last part is the construction sub-trial section that we carried out. So what happening is, like, whenever we do some research work, it is important, essential, I would say, essential for the researchers to compare the findings, whatever you get in the laboratory, shall be able to get very closely in the field. So in attempt of that, this particular task, we have been able to construct a trial section, and in a very brief, I shall be sharing with you. Yeah, coming to introduction part, here in introduction, wherein I'll be briefly talking about the importance of source of the wrap materials and the methods of collections of wrap, and most importantly, the quantity of wrap, the materials which are retrievable from the existing road network of the country. Because the idea to carry out this research work is to narrow down the gap between the demand and supply of the stone aggregates, construction materials, basically, right? So we have a strong feeling that through this technology, we should be able to bridge. We should be, this may be a one way out to bridge the gap between the demand and supply of the construction materials, which is why. So I thought that this is, for me, it's very important to address this part. So I shall be. And by definitions, we can define in this way. It is a material generated when all pavements, asphalt layers of pavements are removed for the purpose of either overlaying or rehabilitations of the pavement, etc. Now, here from this, the cross sections, we can see the wrap materials that I'm talking about is the materials, the aggregates, along with the bitumens, right? Along with the asphalt, I can say asphalt and bitumens, they are same. So I may say asphalt, I may name as a bitumen. So when I name as asphalt, I'm talking about the bitumen. So please you understand me in that way. So this black portions is the bituminous course. Now, depending upon the traffic and the subgrade SOC CBR value, the crust thickness of the pavement section is decided. And based on that, the base course, bound base course, and the weighting courses thicknesses are also decided accordingly. So here I have created a situations for our discussions. In our case, 75 mm DBM and 40 mm BC. That means from the particular road section, I shall be able to get wrap materials from these 2 particular layers only, excluding these WMM, GASB. The WMM is considered as an unbound base course, and DBM is bound-based course, and BC is the weighting course. So now another important aspect to discuss here is the quality of the RAP materials would be again affected by the way of, or by the methods you employ while collecting these RAP materials. So these procurements of RAP material can be done through milling, demolitions, or full depth reclamation. So now in the demolition, it can be done either by sizzling, excavation, ripping, breaking, etc. Right. Now, from this flowchart, what we could understand is, yes, procurement of RAP, irrespective of methods employed, basically the material that I'm going to get, the major chunk of the material that I'm going to get is RAP materials. So that RAP material has to be processed. And then according to this, from this processing, and I shall be able to decide whether this RAP material should be used for this cement concrete pavement construction or bituminous mix, for formulations. Now, this again depends on the bitumen content of the bituminous mixture. So, based on the studies and based on my personal experience, what I would say is, if the RAP material is obtained from the pavement age greater than 10 years, and if the bitumen content is coming down less than 2%, then that kind of RAP material is suitable for both the options, either for flexible as well as for the rigid pavement. Because it is suitable for the rigid pavement for the reason that the asphalt film, the coating around the aggregates would be that, though there may be, in terms of color, it would be black, it would be black brown, but the binding efficacy which is present around that aggregate is now, I would say, in the passive mode. Therefore, it is not going to impart any adhesion property. Therefore, it is a good idea that if you have a choice to use this RAP in the constructions of rigid pavement, and we must go straight away for rigid pavement construction, or otherwise, if the bituminous, the RAP materials that we get is rich in bitumen content, and that kind of bitumen or that RAP material can be considered for formulations of bituminous mix for the constructions of the bituminous courses of the flexible pavement system. This is how, in broadly, I would like to say. Now, coming to the quantity of RAP materials retrievable from the existing road network of the country. Having said that, our country has on about 5.9 million kilometers, as on March 2017. Then, and also said that the state highways and national highways share only 3% and 2% respectively. That means the remaining major percentage, 95% of this total road network belongs to district and rural roads, which is approximately about 5.6 million kilometer road. Now, then accordingly, what I have done is we have tried to work out what quantity of RAP material is retrievable from the available, the road network systems of the country. So for which per kilometer, so for the, for a non-section, what I have done is I have created situations in order to arrive this quantity, for which I have again divided into different category of road. So state highway and national highway in one category, and for the rural roads and district roads in another category. In that way, so I have segregated, and from this, for the calculations of the rural roads, the carriageway width of 5.5 meter was considered, and for subgrade, the SOC CBR of 5%. I have found out the crust thickness of the pavement, and accordingly, the crust of bituminous courses usually recommended for paving this category road was considered and calculated. So per cubic meter of per kilometer road, it comes out to be 825 cubic meter, and if we multiply with 5.6 million kilometer, that is 90%, 95% of this total road network, it comes out to be 462.22 into 10 to the power 7 cubic meter. Okay, so then similarly for state highway and national highway, we have done the exercise in that way. Then the retrievable RAP material is about 428.61 into 10 to the power 6 cubic meter. Okay, and then when I sum together, this two quantity comes out to be 549.71 into 10 to the power 7 cubic meter of RAP material is retrievable. Now, besides this, under the PMJSY3, which was launched in the year of 2019, which has been approved by the government of India, that around 125,000 kilometer has to be widened and revamped with immediate effect. So for which, then again, when we talk about the widening and rehabilitations of the existing pavement, then the quantity of aggregates which would be requiring to meet out this construction project, it comes out to be around again 92.34 million cubic meter of aggregates would be requiring. Now, these are the few the techniques or the methods for procuring RAP materials from the existing pavement site. Now here,
Sorry to disturb you. Yes, sir.
Yeah, please.
Sir,
Tell me.
actually your slide is unpinned. The presentation slide, you have to pin it, and so that everybody will find in the first page itself. Because we are doing the manually, so you are seeing the slide presentation, and there is an option for pin to screen.
Professor Rajiv, is this information for me or for the participants?
Yes, sir. Yes, sir. Yes, sir. For you, sir. So actually, some of the participant is not able to pin themselves. They don't know much about. So if you will pin to the screen to your slide, then it will be visible for all.
How do I do that?
There is an option. If you will take the mouse on the slides, then you will get the first option, pin to screen. No. Pin in the middle of the slide. Yes, sir. Pin to screen. The slide was okay, sir.
Where is?
Sir, your presentation was okay. In that presentation itself, you have to pin it.
Okay. So I go back to my previous slide.
Yes, sir. From here also you can pin, sir.
So shall I actually? Just a minute.
Otherwise, in the people also you will find your presentation, and there also you can pin, sir. By your name, there is a two.
Professor Rajiv, you do,
yes, sir.
No, you tell me, shall I take my the PPT in the slideshow mode or shall,
the presentation
in the slideshow mode?
So actually, in presentation, one is for your video call, another is for your presentation. So there are two names in the people. One is for presenting. So in presenting part, you have to pin it. No, no, sir. Actually, in the middle of the slide, if you will put your mouse, then you will find out pin to screen and the screen itself.
Just I'll do. Okay, just I'll do.
No, sir, not in presentation. On the slide, is simply you move the mouse, you will find three options will come. Okay, no problem, sir. Everybody will do the manually, sir. No problem.
Rajesh sir, I am doing this by myself only. So everybody can do by themselves. Maybe Ranjan sir is not able to do that. So we can do that.
Yes, sir. We will do the manually, sir. Sir, you can continue, sir.
Slides is visible to me. It is okay. No problem from Ranjan sir side.
Is it okay? I'm sorry,
Yes, sir.
my dear.
Just make
I'm
it
not.
full screen,
I'm
sir.
not able to find the option. Actually,
Yes, sir. Just make it full screen.
yeah, I'm taking up my presentation in the MacBook, and then this Mac is not very familiar with me, and then my desktop is again not, allowing me to access
No
this.
problem, sir.
So that's what I have to find the options because I'm very new to this system. Okay. So shall I go ahead with the presentation?
Yes, sir. Yes, sir. Yes, sir.
I'm really sorry. It's my bad. So I was here. Is this slide is visible? Total material required?
Yes, sir.
Rajesh?
It is visible.
This is okay. What I'm trying to confirm, the slide that I'm talking on the right, the thing you are viewing on the right slide. That's what. Okay. So I'm just again, for instance, what I've done is
Sir, the slide is not visible.
slide is not visible. Is it?
No, sir. It is visible, sir. It's fine, sir.
One
Sir, it's fine.
okay, one of the participants, I think, prompted me that
No, no.
is it
No,
okay?
it's fine, sir. It is. Yes, sir. It is okay.
Okay, fine. Then, well, let us continue with our discussion. So then, what I try to understand is for this, the sanction road network, 1.25 kilometer, 1.25 lakhs kilometer of PMGSY roads, right? So for strengthening and for revamping of this road network, what approximate quantity of materials would be required? Okay, that was my thought process. And from this wrap materials, what percentage of materials or conventional aggregates could be offsetted, right? So then for which, again, I have worked out for the widening portions, considering that the 1.5 meter, traffic of 5 MSA and CBR of 5%. Then in that way, the total aggregates required for widening and as well as for overlaying, considering these two, the total material required would be around 92.34 into 10 to power 6 cubic meter of conventional aggregates. I'm talking about the quality stone aggregates. Then, on the other hand, the wrap materials, which is retrievable from the 1.25 lakhs kilometer of road length, about approximately 18.75 million cubic meter, right? Now, my thought process says in that way. If we propose a very ultra thin white topping instead of black topping, right? And having said that, this white topping would, would be more stronger and durable than the conventional flexible pavement, conventional bituminous courses. particularly when I'm talking about the overlaying and the rehabilitation part. So why not? If we can, make use of this material, which is already available on site, okay? We don't have to procure, we don't have to transport the material from far away from the quarries. We don't have to operate the quarries, right? So the material is considered that it is available on site. And at the same time, most of the PMGSY road crosses the habitations. So now, if we keep overlaying, from time to time, the level of road would be increasing year by year. So this particular RAB material, if we remove, and then recast on the same level by giving, the stronger adhesive like the cement, maybe, right? Then by creating this concrete mix, and if we provide as a, ultra thin white topping on the concrete on that particular road stretch, it is going to save only in terms of construction materials about 15%, excluding the time, time required for excavations, getting material from the quarry, transportations, and again the dumping stackyard, you would be requiring additional, and then machineries, manpowers, everything, and all so forth. This I'm considering only on materials. About 15% total aggregates requirement can be brought down. Now, why we would be able to do so? The reason being, when in the left corner of this, what I'm trying to say, I have dissected the from the bituminous core sample. Now, if you look at here, this particular RAB materials comprise of filler of about 3 to 5% maximum, and the bitumens ranging from 3.5 to 6% maximum. In that way, the combined coarse and fine fraction, the percentage would be around 89%. Therefore, basically, RAB material is a good quality material. Therefore, we do not want to throw away, unnecessarily, or we do not want to use this RAB material in the lower layer of the pavement construction. Therefore, we are trying to venture out a mechanism by which these RAB materials can be judiciously, again, recycled or reused. Now, in this discussion, the important things that we need to keep in mind is that, because based on the certain, mechanism, certain activities, the quality of RAB is likely to be affected. So, what are they? The first one is, yes, as I mentioned earlier, methods of procurement adopted, and maybe of milling methods. In the milling methods, you can have, the excavation by or employing the asphalt milling machines, or by sizzling. Now, see, the kind of RAB material that we are going to get from these different methods would be different. Reason being, if the RAB is being obtained through asphalt milling machine, because it is properly chopped out. By this process, ensure the chopping of this bituminous cores precisely, without much of contamination. Without much of contaminants, I would say in that way. But whereas if the same RAB from the same pavement section, if we happen to procure by employing different methods, say by excavation, right, by employing some JCB, then the kind of the quality of material that we are going to get from that same section would be different. Reason being, when excavation, we don't have the control. That's what we say, uncontrolled. And the milling machine, employing a milling machine and obtaining RAB is under control. So in the uncontrolled manner, if we collect the RAB materials, then the kind of material that the RAB material would be slightly, graded in nature, and there would be foreign matters presence would be, the chances of the foreign matter presence is very high, because it may dig down, because it is being done in a very uncontrolled manner. So the materials, the beneath, the layers are also likely to intermix with the RAB materials while collecting it. And another important issue is, yes, the service life of the pavement and stockpiling, if any. Suppose service life of the pavement is known to us. Maybe suppose for a young age pavement and all age pavement according to the bitumen content that we have discussed. Now coming to stockpiling. Why stockpiling is coming into picture in this discussion? Yes, at times it shall happen, particularly for the developing countries like in India, where we do not have a proper methodology to process the RAP materials. Normally, depending upon the requirements of the projects and the contracts agreements of the projects, we deal the situation in that manner. Say, if the RAP material procurement, RAP material recycling of RAP material is not in the provision, then or which comes up to be in the later stage, then what happens? That in that case, we have to remove this bituminous course and again take this bituminous course to a dumping yard in a proper dumping stack yard and properly stacked, and then as and when required, this material can be again retransported to the construction site, and then after ensuring proper processing, that same material can be reused. It's being reused. This is how we are doing as of now, right? Therefore, stockpiling is again another important issue. Now, in the stockpiling itself, the RAP material that we are obtaining, right? If say from this picture, you can see from this slide, the RAP material is collected. The RAP materials are collected in the block form. Here, the RAP material is being stacked in a this is being obtained through milling machine. So it has been properly milled and it's pulverized, and the more surface area is exposed to this weather in comparison to this. Now here the lesser surface area is exposed to the weather condition. Therefore, the aging process during the stockpiling, in comparison, when we compare to these two methods, the aging process would be rapid in the case of here the RAP materials which was obtained through milling machine. This is that. So now, depending upon the nature of the project and the quantity of the RAP availability, we have to take a call. Now, then here we are using worst conditions and favorable condition. Favorable condition means here it is pertaining to the concrete mix, okay? And worst condition is again, which is with respect to concrete mix usage only, usage of RAP in the concrete mix. So now, guess what? Based on our research work, we have found that control milling is good for flexible bituminous mix, and uncontrolled milling is good for the rigid pavement construction in that way. Then, depending upon the aging of or the bitumen content of the RAP material, we have to take a call. So I hope you follow me. If there is any confusion, you can catch all of me at last. We can discuss. Now, the concern is how and when shall we take a concrete decision that the removal of the existing bituminous course should be done. Now so therefore that we have to understand the pavement deterioration's conditions. This needs to be explored beforehand. Now, as we know that the deterioration condition has been marked by 4 performance indicators. Namely, the one is unevenness index, the roughness, which is basically roughness of the pavement. It is being measured in terms of International Roughness Index, IRI, and the surface modulus and rut depth and frictional coefficient, etc. And also, if suppose, and also having said that, the asphalt surface is considered to be good if the unevenness index is less than 2000 mm per kilometer. And on the other hand, if this UI is greater than 3000 mm per kilometer, then it is considered to be, again, not a it's not a good condition or not the ideal conditions to apply traffic on it. So in such situation, overlaying activities comes into play, and if this the intention is intended, then we need to understand the pavement history, compositions, the types of layer, thickness, and year of construction, history of intervention. Maybe like the overlaying must have been done, prior to this activity, right? And then is it for the resurfacing or reconstruction? Now this all would depends on the structural evaluation. Then we need to evaluate the structural properties of the pavement system, which can be done. One of them, there are many methods, but one of the suitable method is being done by the employing falling weight deflectometer. So this particular method is capable to map the residual life, and we can project the overlay requirements. Then from the collected existing pavement materials, we need to understand that material like that sample can be drawn through the core samples, and the properties of the aggregates and binders can be ascertained, and then we can try to understand that the aggregate gradations, that what is the aggregate skeletons of that existing pavements, and then the binder content, viscosity of the binder. See, this is now here the viscosity of binder, bitumen content, viscosity of the binder plays a pivotal role in deciding the the removals of the wrap materials. Coming to utilizations of wrap in the current scenario and the challenges that we are facing as on today. Now, see, wrap materials are being used in flexible pavement constructions under 5 different aspects of recycling. One is reclamation, hot or cold processes, hot in place recycling, which in short we write HIR, and then cold in place recycling, CIR, and hot in plant recycling, cold in plant recycling, so on and so forth. I'm not going to discuss this, but this is how the wrap materials are being used in the flexible pavement construction. So that I would like to just mention during my presentation. That's it. Then what are the challenges that we are facing still today, despite of having some preliminary guidelines and well-established guidelines for uses of wrap materials in formulations of the bituminous mix? Yes. See, I just would like to point out 2-3 points. Now, as per Mode Clause 519.2.5, when the amount of wrap is to be used in the bituminous mixture exceeds 10%, the penetration value of recovered binder from the reclaimed material before mixing cell exceeds 15%, 15 penetration value. Right. Then, again, from the available literatures, it says that the current agency specification typically indicates that 15% wrap. See, and then again in the next, when the wrap contains a mix is between 15 to 25% by weight. Like, so see, now what I want, my thought process pertaining to this particular slide is that even if we are using wrap materials in bituminous mix formulation for constructions of flexible pavement, we are able to do max to max 25% or 30%, not more than that. But how about for the remaining wrap materials, which have been left aside? So that's the point. So now, therefore, it is imperative for the researcher, academicians, and scientists to venture out a mechanism by which this 100% wrap material can be utilized for the construction in the constructions of pavement. That's how. So I'm not going to read this slide. Now, that's what. Why wrap in PQC in rigid pavement construction? That was the question that I had, way back 6-7 years ago. Now, the statistics shows that wrap is generated maximum in United States, in the world, and the maximum utilizations of wrap is also being reported in US, but more than 70% remain unused. Been reported to remain unused even after its effective utilization for different bituminous pavement applications. So, my dear friends, we have to understand this part, right? Now, hence, it is imperative to find a way out by which the higher percentage utilizations of wrap is ensured in the constructions of the pavement without compromising the structural integrity of the pavement structure, which is why we are focusing on the rigid pavement construction. So can it be done? So now that study part I'm going to take up. Now, as I mentioned that earlier, constructions of rigid pavement, I cannot ignore the DLC layer construction. And then I cannot say that we have to construct a rigid pavement, okay, just right on top of this compacted subgrade or compacted GSP layer. So DLC layer is being served as a upper subbase layer, which ensures so many things about the integrity of the pavement systems is concerned. Now, this layer that is again provided to mainly to give a evenness surface, to provide a evenness surface, so that when these PQC slab lay on it, there shouldn't be any undulation on it. And also in some localized capillary section, this also serves as a capillary cutoff. And and also most importantly, it is also contributing towards the overall strength, structural properties of the pavement system. Now, in order to construct the DLC layer, when I confine to only the mix part, not the construction methodology part, it says that as per Mod Clause 602, it says that the concrete mix, which is capable to produce 10 MPa at 7 days moist curing, is more than enough for casting DLC layer. Now here somewhere, because now you guys are some of you are young researchers and students, you might have to read so many articles, documents. So for which I would like to first of all clarify that 7 MPa is recommended in IRC SP 49, whereas in Mod Clause 601, this requirement 10 MPa is mentioned in that particular yellow book. Okay, so that's what I have written here. 7 days compressive strength shall be at least 7 MPa/10 MPa. So this is the prerequisite, or I would say the requirements of the concrete mix to qualify to serve as a DLC mix. Now, and also having said that, as per Mod Clause 601, the concrete matrix that you are going to formulate for DLC mix should have a ratio, maximum ratio between aggregate and cement, okay, of 15:1. Therefore, in our research work, what we have done is, see, as I increase the ratio of aggregate, the more economical would be the cost of would be for the mix. Therefore, what we have tried for 12:1 ratio, and the coarse to fine ratio was maintained 62 and 38, 62% and 38%. And cement content, the minimum cement content recommended in the Ministry of Road Transport Highways, Clause 601 is 150 kg per cubic meter. Hence, we have tried with this minimum recommended cement content per cubic meter of concrete. And then accordingly, we have formulated the mix. And as for your kind information, especially this information is for the UG and the PG students who are not well versed with the rigid pavement construction. Having said that, the DLC mix shall not be designed, following the Abraham's law. That means water cement ratio. We are not going to follow the water cement ratio. We are not going to follow the Abraham's laws while formulating the DLC mix. We are rather go by the compaction methods, okay, standard Proctor tests. So for which we have prepared the standard Proctor test, and we have mapped the OMC and MDD for the different wrap materials incorporations levels, and then try to find out the best possible incorporation levels. And the best possible incorporation level is defined here in our study. The percentage of wraps which when this RAP is included in the concrete mix, and which is capable to achieve at least 7 MPa or 10 MPa, then that is considered to be the you know a qualified DLC mix. Now, what happens? What sorts of observations we observe during the course of the laboratory investigations when RAP materials is incorporated into the conventional concrete mix? Yes, we have tried for several, replacement level, 25, 50, 75, and 100, and so on and so forth. But out of these findings, out of these percentage, the decided percentage replacement levels, we have found that, yes, coarse RAP, since the work was undertaken under two different heads, one for coarse RAP, one for fine RAP. So if coarse RAP has to be incorporated, then up to 75% natural aggregates can be part replaced by RAP materials. And whereas for the fine RAPs, up to 50% fine RAP can be incorporated. Right? By incorporating this RAP percentage level, we are able to achieve the compressive strength of at least 10 MPa at 7 days. Okay. Now, the observations that we had during the course of investigation is like this. For the fine RAP, as you know that when we part replace the fine material matrix, and the fine material would offer more surface area, the requirements of the lubricants would also be accordingly more. So it is one of a small example that I would like to show you that during the laboratory study, that this kind of situation we have come across. So from this graphical plots, we could see the patterns of the moisture content corresponding to the MDD, right? MDD corresponding to the moisture content, let me put it this way. Now, as we increase the percentage replacements of RAP, right, the density decreases and the requirements of the moisture is increasing. This is the decreasing in density is owing to lower specific gravity of RAP materials, okay, and also then having the more surface area of the matrix, the demands of moisture is slightly higher. And the picture is the picture captured during our trial sections. We have that I'll be discussing later in the following slides. So this is for the control DLC, which was the DLC slab cast using the conventional concrete mix, and this is the DLC slab prepared with the RAP inclusions. Now, from this finding, as I mentioned earlier, that we have tried for the different replacement level that we could see here. This is one of them is for compressive strength, and then another is both of them are for compressive strength, but the top one is for the coarse RAP replacement study conducted, and the lower one is the performance of compressive strength obtained when fine RAP was part replaced the fine materials, fine aggregates. Okay. Now, some of the difficulties that we came across while part replacing these conventional aggregates by coarse RAP and fine RAP are like, one is reducing moisture content, increasing moisture content, and then decreasing density, right? So these two main reasons are mainly due to this asphalt film, presence of asphalt film around the aggregates, which hinders the and the agglomerated particles of the RAP materials, which are sticking around the aggregates, and also due to lack of fines. Okay, because due to lack of fines, which eventually leads to poor quality of cement paste, right? So therefore, the lower density of this DLC mix was observed, and also at the same time, due to presence of these agglomerated particles, the degree of interlocking within the DLC matrix, aggregate matrix, could not be held, tightly. So as a result, the density is decreasing, and at the same time, compressive strength is also decreasing in comparison to the control mix. Now, then, in order to understand better, what we have done is we try to capture the same images, try to understand this particular same images were taken from the mortar study only, not from the coarse and the fine wrap, not for the coarse aggregate, coarse wrap materials. This is for by including the fine wrap, and we did try to understand the mortar performance. What exactly is happening in the interfacial transition zone with the aggregate particles and the hydrated paste. So in order to understand better, when we work out, we could see that when we look at this NA represent for natural aggregate, RC represent for the coarse wrap materials, and this ITZ mortar is for 100% fine wrap, and ITZ for 100% wrap. So here, what we try to use is the different percentage of fine wrap was part replaced, was included by part replacing the fine aggregates. And then when we observe the this microstructure, we have found that yes, due to presence, there is the interference of asphalt film presence around the aggregates, because of which we are not able to improve the compressive strength and the density. Now, from this slide, here few of these pictures I have put here just to deliberate on these agglomerated particles. Okay, we can see here clearly, this is the coarse aggregates, with a substantial amount of agglomerated particles around here. And basically, now this particular picture, this particular image has been developed by Dr. Surender Singh during his research work. And we try to understand that exactly what happening is this is the core of the aggregates, and just on top of the core aggregates, this asphalt film is engulfing around, and again followed by the now here is stiff dust and then loose dust. Now, this kind of phenomena is usually observed from the wrap aggregates which have been, kept in the stockpile. Okay, in the suppose a stackyard, if you keep it for a longer period of time, because the contaminants would come and stick around the wrap materials, which is why there would be 4 different types of layers, including the asphalt film thickness in the wrap materials. So now the purpose of discussing this particular phenomena is that, see, as we understand concrete matrix, we can establish a good bonding between the coarse and the hydrated cement paste properly when there is a good contact at the interface of the coarse aggregate, right? So for which now this, in the case of wrap material, it is not able to do so. The reason being, due to presence of this asphalt film around the aggregates, which doesn't allow this hydrated cement paste to come and form a bond. Therefore, we try to work out a way out by which this asphalt film is removed from the aggregates. Yes, there are many methods, by chemical methods, by mechanical methods, we can do that. By chemical methods, yes, there is a high probability to affect the quality of, number one, quality of the aggregates because of the chemical reagent that we use. And secondly, it will be uneconomical because it's very expensive. We can use benzene, we can use chlorethylene, we can use toluene, and so on and so forth. But it would not be economical, right? Therefore, it would be very expensive. Therefore, what we have done is we were hunting for a mechanism, a very simple mechanism, and which is very doable, by which this asphalt film can be removed as much as possible. And if 100% removal is not possible, then to what extent we can remove, or else can we puncture this asphalt film coating around the aggregates and try to create a number of windows around the aggregates, and through which this bonding can be taken place. That's how, with the concept that we have worked out. And now the discussion, I just take back here that the discussion was very brief on the DLC mix establishment. Now I'll take you to the wrap material for PQC mix formulation. Now, for the, I would say let me put it this way. Formulations of concrete mix for DLC construction, formulations of PQC mix for constructions of PQC, cement concrete slab, they are different because the methodology itself is different. Because in case of PQC mix establishment, we have established guidelines we follow according to IRC 44. Today we have IRC 44 2018. Now, but having said that, whatever the methods you employ, the basic things that you have to understand is the physical properties and mechanical properties of the aggregate. That property should, meet the specification, required specification. So, in order to do that, the collected wrap materials. See, I'm a little bit shortcut. Okay, this discussion is a little bit short due to the paucity of time, because otherwise, only in this slide, I have, maybe I may require around half an hour to deliberate on it. But I'll do a bit of shortcut of this. Yes, the physical properties of the considered aggregates needs to be evaluated beforehand. For which, what we have done is only, now I'm not showing the conventional aggregates. Okay, here conventional aggregate is now we considered it's okay, perfectly fine. But in coming to wrap materials, the coarse wrap separated from the wrap materials are shown here. This is the coarse wrap as received state in the when we receive without giving any beneficiation. Okay, and this is the wash wrap. If we happen to wash this coarse wrap, okay, with the help of the potable water, then this is how the aggregates conditions would look like. And if we adopt the abrasion and attrition methods, this is the new methods we have venture out. We could venture out through this research endeavor. So through this, the beneficiated ATB method was employed. Through this, we are able to puncture the asphalt film. There are some of them are free from the asphalt film, right? So this is that. Then based on this, we try to evaluate the physical properties of the aggregates. Okay, so then they are being presented here. Now from this study, we have learned that yes, water absorption is slightly more. Water absorption is, I would say, more in case of wrap materials because of the presence of these contaminants, dust layer, and all and so on and so forth. But whereas if we look at the counter natural aggregates, it is around somewhere 0.7% also. And even in terms of aggregate impact value, now coarse wrap, the wrap material offers lesser impact value than the natural aggregates. And this is again this is being influenced by the presence of asphalt film of the aggregates. And similarly, but in the crushing value and so on and so forth, we have worked out. Now, I'll take you to the concrete mix formulations as well as here in my discussions. I'm sorry, some of you may be quite confusing because I'm taking you here and there and then try to complete my presentation. So if you are not able to follow me well, please you can ask. You can pen down for the question and answer session so that I can. I'll try my level best to answer you back. Okay. So what I'm trying to do here is from this slide. PQC mix is being formulated, right? Then the PQC mix, the grade of concrete that we consider is M40 grade of concrete, and the formulations of the concrete mix was done as per IRC 44. And yes, here the important point to note is in Mod Clause 602, it says that the cement content, the maximum cement content for rigid pavement construction, okay, cement content for concrete mix for constructions of rigid pavement is 425 kg per cubic meter. It should not be more than that. The reason being here, if we add more cement content in the concrete mix, there is a high chances to have shrinkage cracks effect in the concrete matrix. So in order to prevent or in order to avoid this kind of unwanted shrinkage cracks, appearance on the concrete surface, so the maximum cement content has been limited to 425 kg per cubic meter. Therefore, since here our study is pertaining to what? Replacement of good quality aggregates by slightly inferior quality of aggregates. Therefore, considering this factor, we have decided to go with the maximum recommended cement content for the concrete mix for the constructions of cement concrete pavement. And water cement ratio of 0.38 was adopted. Then concrete mix was prepared and the study was conducted for the different beneficiation methods. So when I say different beneficiation methods, washing is also one of the beneficiation methods we have adopted, and abrasion and attrition method is also another method. Okay, so now from these different beneficiation methods, but here we are not considering the chemical beneficiation methods. Okay, so from this, the abrasion attrition methods offers better results. Therefore, we have decided to pick these methods, to adopt this method for further course of action. Now, the data that I'm presenting here is without admixing supplementary cementitious materials. Only need part replacement of conventional coarse aggregates by the wrap materials. Is it okay? So this is an small example that I wanted to show you that the shrinkage cracks happening on the concrete slabs. Okay, so in order to avoid this kind of cracks, we have to limit the cement content per cubic meter of concrete. Now these are the graphic bar charts prepared from the findings of the laboratory studies. Now, for the different percentage replacement level, 25%, 50%, 75%, 100% we have tried for. This is our study now here in this slide. It is confining to only abrasion in attrition methods. We are not talking about the other beneficiation methods. Okay, so through this, if this method is employed, then incorporations of RAP 50% is feasible for PQC mix. Because now at mixing of these RAP materials, the benefit that we get is which enhance the workability considerably. And so hauling time, the setting time of the concrete mix considerably reduced. Therefore, now what we have found is by incorporating RAP materials, we are able to enhance the workability, and therefore for paving work, if suppose at times it should happen at the construction site, the batching plant is installed in the central locations of the project and the mix is being dispatched on the either way. So if this kind of problem arises, the transportation, the hauling distances and the problem, then the incorporations of RAP would considerably, I would say, help in number one, improving the workability, and also would ensure the longer distance, transportations of the mix without much affecting the workability of the concrete mix. Then, 50% replacement level is recommended considering the modulus rupture of PQC mix. Here, there are, as we know that in the mechanical properties of the hardened concrete, we normally look at the compressive strength and the flexural strength. That basically modulus of rupture of the concrete. Right? So in case of compressive strength, the improvement in compressive strength was not exist when the conventional aggregates was part replaced by the RAP materials. Whereas in the case of flexural strength, though there was a reduction. There was a reduction in the strength, modulus of rupture, by when we incorporate the wrap materials, okay, by part replacing the natural aggregate. But it is now by but it is more feasible, or I would say more appreciable flexural strength is achieved in comparison to compressive strength when the natural aggregate is partly replaced by the wrap materials. So now what is that? The desirable modulus of rupture, as per mod clause 602, it says that the concrete mix, which is capable to produce at least 4.5 MPa modulus of rupture, is suitable for the constructions of rigid pavement. So as a result, the basic target is to achieve this minimum 4.5 MPa modulus of rupture. So now in this context, what we have done is this 50% wrap percentage is fixed based on the flexural strengths of the concrete. And also we have tried, why not? Because our attempt is to maximize the percentage replacements of natural aggregates by the wrap material or waste the recycled aggregates, right? Therefore, since we have understood by adopting abrasion and attrition techniques, we are getting the better results of the concrete properties. So therefore, we thought of replacing 100% natural aggregates by the wrap materials. So in doing so, we have again kept the cement content constant, and here we have admixed silica fume, fly ash, and sugarcane bagasse, because these are the some of the mineral admixtures, rather I would say pozzolans. Okay, they have their own different efficacies. Therefore, silica fume is well established pozzolans, but fly ash too. But fly ash has some the corners of not to fulfill 100% pozzolan material at times, depending upon the crudes. Now, therefore, attempt has been made to look at the mechanical properties of the hardened concrete by incorporating these different mineral additives. Then, from this bar chart, we can see the details, but I would like to conclude here. Higher improvements in flexural strain as well as in the compressive strength was offered by the mixed combinations having silica fume 10%, okay, and followed by bagasse ash 5% and fly ash 20% respectively. Now, irrespective of the replacement level for the compressive strength and of modulus of rupture, all of these considered mix qualifies the minimum stipulated compressive as well as the modulus of rupture. The only thing is that we have to admix these mineral admixtures in recommended dosages. And we have in our the research endeavor, we have studied the durability properties of concrete, but I'm not going to address here. Now, here, after the laboratory investigations, after a comprehensive laboratory studies, what we have done is we have attempted to come up with a trial section, okay, trial page, wherein we have decided here the trial section shall have at least 4.5 meter of slab span and a 3.5 meter width of slabs, and having a solder on either sides of 0.5 meter each. That basically the tight concrete solder. And why? Because condition is required in IRC 58 2015. When we design, there are conditions for tight concrete, tight shoulder and untight shoulder, without shoulder. So we have considered for the tight concrete shoulder while designing the rigid pavement section. Now, from this cross section, here what I'm trying to show is, here we have tried to map the temperature differential. Okay, the temperature differential map at the top and the bottom fiber of the concrete slabs. So in the though this trial section was done at the outside of the laboratory, the limitations of this trial section is that it is not a traffic road, but this particular rod section is completely exposed to weather effect. Okay, the weather. So now, to some extent, this particular trial section, particularly for temperature differential study, we are going to get almost a true value, true data, for which we thought of going with this trial section. Now, in the constructions of this trial section, now the GSB layer that we have considered 150 mm and dry lean concrete of 150 mm and PQC slab 280 mm. This particular truss was designed for the traffic of 6,000 commercial vehicles per day, both directions, in accordance with ILC 58 guidelines. And we have considered that the CBR subgrade, value was about 10%. Okay, because this particular rod section, trial section was carried out on the existing pavement section, and we have assumed that there has been a sufficient consolidation effect. Okay, therefore, the subgrade CBR of 10% was considered. And for the constructions of this trial section, it was a 50 meter, but what we have considered is for 9 meter, 4.5 meter, 4.5 meter for conventional, 4.5 meter slab is for conventional concrete mix, and another 4.5 meter span is for the concrete mix incorporated with the wrap materials. Now, how did we do that? That I would like to explain here. Here we can see in the CR2 and CR1. Now CR1 has this is the wrap materials obtained from different source, and the CR2 is also a wrap obtained from the different source. So let me, to simplify our discussion, let me come up in the manner, with respect to bitumen content. For CR1, the bitumen content of the mix was around 3.21% here, and the CR2 has a bitumen content of around 2.48% by weight of mix. And the coarse aggregate sizes of 20 mm and 12.5 mm of conventional aggregates were part replaced by wrap by the similar size of aggregates. And in the constructions of DLC layer, now here 100% CR1 for DLC with 30% extra cement we have added. Reason being, because in this CR1, this is relatively greener, and relatively it is in wetter side in terms of bitumen content. Therefore, this particular wrap material could not produce the desired strength, compressive strength of the DLC. Therefore, we have decided to go by adding 30% extra cement content. And when we add 30% cement content, 30% extra cement content in the DLC mix, we were able to achieve the desired compressive strength of the DLC. And similarly for PQC slab construction, we have considered 65% this using the CR2, because it is comparatively cleaner aggregates in terms of the asphalt content. So, but without supplementary cementitious materials. So now the construction is now has taken place in this manner. The wrap material that we have obtained, this material was used in the DLC construction, okay, and 100%. And this is how the GSB layer was prepared, and the DLC layer is being casted here. And the difference of the DLC layer of the conventional and the concrete mix prepared with the wrap material is being shown here. And by appearance, by visual effects, there is no different at all. And on top of this DLC layer, a separation membranes, 125 micron thick, is provided as a separation membranes. This is being sandwiched between the DLC layer and the PQC layer to act as an anti-frictional layer. Okay, and there are many distinct purposes of having this. One of them is in order to break the bond between the DLC layer and the PQC slabs. So this is how I'm coming almost completing my presentations. I hope you all are following me well. Now, after this construction, the PQC layer was constructed, and then during the construction, what we have done is, I'm sorry. Here, this is the thermocouples. The several thermocouples were embedded, were inside the concrete matrix as, one at the top and one at the bottom of this concrete slab, so that the temperature sensed by the slabs through these thermocouples can be recorded properly, so that the temperature differential happening at the top and bottom of the concrete slab can be analyzed properly. Now, and then thereafter, concrete PQC mix is poured, and then after that, this is the natural NA is the PQC slab constructed with natural aggregates, and this is the concrete slab constructed with the wrap materials by part replacing the natural aggregates up to 65%. And this is the falling wet deflectometer measuring the mechanical properties of the concrete for different these pavement sections, for the natural aggregates, and for the wrap materials. Now, this mapping has been done in such a way that we have done one at the corner, one at the edge, one at the interior of the slab. Then the average value of this FWD was noted, and this FWD was conducted in accordance with IRC 117. And then accordingly, the modulus of rupture, compressive strain and modulus of rupture was found. And from this finding, we have understood that, yes, 65% part replacement of natural coarse aggregate is very much doable. Okay. Then, from the temperature differential study, what we have learned is, because the main purpose of conducting this task is to check the combined stresses, which is basically, we are hello.
Yes, sir, we can hear you, sir.
Oh my God, thank you. Okay, so through this exercise, we were able to map the temperatures at the bottom and the top of the concrete fibers, and here this is the curve which shows the maximum temperature differentials for both the slabs. And yes, for your kind information, I would like to mention here, here during our study, the month of June was proven to be the hottest month. So therefore, we have taken the June month for the further study. Then the maximum positive temperature differential map from the control slab was 7.6 degrees Celsius, and from the wrap slab was 5.7 degrees Celsius. And then maximum negative temperature differentials map for the control slab was 3.1 degrees Celsius, and the wrap slab was 1.7 degrees Celsius. So that means from this finding, it is quite conspicuous that the maximum, the positive temperature differential and the maximum negative temperature differential in both the cases, the wrap incorporated, the slab, PQC slab is giving lesser pavement temperature differential. So what is the benefit that we have from these findings, this. Now, as we know, when we design the rigid pavement slab, we consider the stresses. Okay, stresses under the wheel load and stresses which is going to happen under the effect of curling, stresses. So now, from these two different equations, this one equation, the first equation is for mapping the stresses, okay, flexural stresses for the bottom-up cracking and for top-down cracking is given here. This delta T, this is the change, the temperature differential. This is this temperature differential we map here. This temperature differential has to be substituted here. So here, smaller the delta T value, the better is for the stress. Better is, I would say in that way, better is for the rigid pavement this thing crust, because we are going to get the thinner slab thickness, because the curling stress effect is minimized, lower. Therefore, we would be able to design the PQC slab in a thinner way in comparison to the conventional concrete PQC slab. Okay, despite that the flexural strength is slightly compromised in comparison to conventional concrete mix, but here, due to this temperature differential, due to the lesser temperature differential accrue out of this wrap slab construction, we would be able to economize the slab section considerably. So, from these findings, we are suggesting that incorporations of wrap aggregates would not only reduce the cost of the materials, okay, will not only offset the consumptions of the construction material, but would also reduce the PQC slab thickness due to the curling stresses. This is how I would like to conclude my presentation for today. In fact, it is the work of 3 years span done by the different researchers. So it is not possible for me to share with you the entire findings, but yes, some of the highlights that which I would like to do, that I have done it. So now I would say thank you to all the participants for patient listening. It seems I think I have taken quite a lot of time.
Thank you, sir. Thank you. I greatly appreciate the presentation you gave about reclaimed asphalt pavements. It was very nice and it was nothing short of informative and interesting. So if any queries are there, participants, you can post them in chat box.
Professor Rajiv?
Yes, sir.
Then you may have to help me again. Now here you have to help me in this process. Shall I go back to the? Shall I remain this thing?
Sir, you go to the Google.
Okay, shall I go to Google?
You can go to the Google Meet, sir. Google meeting.
Okay.
And stop sharing, sir. The option will come. Stop sharing.
Stop presenting.
In people, there is a list of people. Also, there also you can find your name. Otherwise, on the same slide, you can stop the sharing, sir. Otherwise, it's okay, sir. No problem, sir.
Yeah, I am audible to them, right?
Yes, sir.
Yeah. Anyways, please.
Yes, yes, seeing, sir.
If any queries from the participants, I would love to address if I am able to do so. If I cannot, I will say sorry.
So it was really very nice presentation, sir. Thank you so much. And I think participants loved every second of it.
Thank you so
there
much.
is one doubt in chat box. He is asking, sir, can you throw light over why to use wrap over other things, as it is much difficult to use them efficiently?
Okay. Are you done with your question?
Yes, yes, sir.
Yeah. See, yeah, it's a very good question. Thank you for uh, uh, giving me this a very thoughtful this thing questions. Right. See, wrap materials. Why we are working on wrap materials is we have to first of all understand the requirements of the construction materials, okay, in today's time. Now, let me put in this way. In the country, in the nationwide, I would say by NGT, okay, has banned the operating stone quarries. And at the same time, on the other hand, the national importance infrastructure project is booming up. Now, as a result, there is now huge gap between the demand and supply of the good quality aggregates. Now, therefore, everyone is now looking at the recycling of waste materials. Now, when I say recycling of waste materials, which includes the construction and demolition waste, now the major chunk of the aggregates that that we can accrue aggregates out of these activities are like recycled concrete aggregates can be obtained from the concrete structure, maybe from the beams, slabs of the building, demolished buildings, right? But in the case of in case of road construction, since this raw material is available on site, okay, is this material is already available, on site. We don't have to transport the materials. We don't have to hunt around. Okay. So if this material can be, reused or recycle it for the constructions of the same stretch of the roads, then it is going to help us immensely. Okay. Not only in terms of economy, but also environmentally. Okay. It would be beneficial for us. Now, uh, do you need more elaborations, or else this is enough?
Yeah, it's enough, sir. There is just one more query by
Yeah.
Bhupati. When we incorporate RAP in PQC, is not there problem of binding between existing asphalt layer in RAP with the cement?
Yes. Yeah, I did mention during my presentation. Yes, it does. Because, see, the wrap aggregate is completely engulfed with the asphalt frame. As a result, there is a difficulty in, having good bonding at the interface of the aggregates and hydrated cement paste. So as a result of which, what we have done is, yes, that's what I here two important the same aspect I have recommended. Number one, wrap shades of wrap for constructions of rigid pavement can be recommended when for the pavement having service life more than 10 years, and if the bitumen content of that bituminous matrix is less than 2%, then we can go for you know uh, reuse of the same for the constructions of rigid pavement. This is one. I hope you understand. Now, then another is, yes, it might so happen that yes, some asphalt films are still coating around the aggregates, and which is the binding efficacy is also still good. In such circumstances, we can employ the abrasion and attrition methods. Basically, the aggregates would be subjected to the mechanical beneficiation. Okay, and then through this mechanical beneficiation methods, some of the aggregate asphalt film would be removed. Then which ensures the coating of hydrated cement paste firmly with the coarse aggregates. This is how we have recommended using of wrap material for constructions of rigid pavement. In these two ways, we can decide. Hello.
Yes, sir. There is last query of the evening. How we can find out the thickness to be cut like only wearing course or base course? I repeat, how we can find out the thickness to be cut like only wearing course or base course?
Yeah. Normally, the normal practice is like, I said that, see, the pavement conditions study needs to be carried out beforehand, okay? And if there are distresses, then the aging of the existing pavement is significant. In that case, what we do is we can drill a core sample. A core sample can be drawn from the existing pavement section, and through which we would know what is the thickness of the bituminous course. Because it is a very good, very good questions. The reason being, like, see, now during the design, during the construction stage, okay, depending upon the crust thickness based on the traffic requirements and the subgrade value, suppose we might, we might have got, suppose X, like I would say like 150 mm, okay, for both. 100 is for DBM and 50 mm is for BC. For example, I'm creating a situation here. And now in due course, the pavements, the riding quality, the gradually comes down. As a result, we do provide, we have the different stages of maintenance, right? Routine maintenance and renewal, periodical maintenance, so on and so forth. So in such cases, if there is any surface renewal upon this 50 BC, if some, in other times another 50 mm BC has already been provided, then we would be able to precisely determine the total thickness of the bituminous course. Then accordingly, what we do is, if we happen to employ asphalt milling machine, then that asphalt milling has the capacity to fix only the required depth. Now we can say, for example, now it was initially 150. Now since another 50 mm has been added on, so now the total thickness of the bituminous course is 200 mm. So now this 200 mm thick bituminous course can be precisely chopped out. Okay, can be mill off with the help of the asphalt milling machine. I hope I answered your query. Hello. Hello.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much, sir, for giving me so depth knowledge about the rap. And I think most of the participant has understood what is the future of the rap also, and what is the present condition of rap research is going on. So I hope everyone has learned so many things from you, and thank you lot, sir.
Pleasure is all mine, and thank you very much. So, are you concluding now?
Yes, sir. Thank you, sir.
Okay, thank you so very much to all of you, to the organizing team and the participants for their patient listening. I really appreciate it. Thank you so very much for listening me. So shall I check out?
Close, sir. Yes, sir. Yes, sir.
Bye bye. Take care.
Huh?